Welcome to the lecture. In this lecture, we are going to discuss about the 8051 serial communication. So, when a microcontroller communicates with the outside world, it provides the data in the byte-sized chunks. So, in some cases, like printers, the information is simply taken from the 8-bit data bus and presented to the 8-bit data bus of the printer. So this can work only if the cable is not too long, since long cables diminish or even distort signals. Furthermore, 8-bit data path is expensive. So for these reasons, serial communication is used for transferring data between two systems located at the distance of hundreds of feet to the millions of miles apart. So let us see here. In the figure 1 shows the serial versus parallel data transfers. The fact that serial communication uses a single data line instead of 8-bit data line of the parallel communication. As you can see here, we have only single data line for transmission, and here you can see from D0 to D7 we have 8 parallel lines. So for the fact that serial communication uses single data line instead of 8-bit is that for serial communication to work, the 8-bit of data must be converted to serial bits. So for serial communication, the byte of the data must be converted using the parallel and serial out shift register, and then it can be transmitted over a single data line at the receiving, and there must be a serial in parallel out shift register to receive the serial data and pack them into the byte. So here we can see when the distance is short, a digital signal can be transferred uh, as it is simple on the wire and requires no modulation. However, for longer distance data transmission, serial data communication requires a modem to modulate and demodulum to demodulate, right? So let us discuss about the serial data transmission, and let us discuss about the synchronous and asynchronous type also. So it is of two methods as we have discussed, asynchronous and synchronous. So let us discuss about the synchronous type. The synchronous method transfers the block of the character at a time. That is, you can see a block of a character at a time, and while the asynchronous transfers a single byte at a time. So there are special ICs made by the manufacturers for the serial data communications. These chips are more commonly referred to as UART, that is Universal Asynchronous Receiver Transmitter, and USART, that is Universal Synchronous Asynchronous Receiver Transmitter, which we have discussed in the third unit lectures. And you can see here we have various types, like if the data can be transmitted or receiver, it is a duplex transmission. In this contrast to a simpler transmission such as with printers, in which the computer only sends data. Duplex transmissions can be of half duplex or the full duplex, depending upon whether the data transfer can be simultaneously. If the data is transmitted one way at a time, it is referred to as half duplex. If the data can go both the ways at the same time, it is a full duplex. Full duplex requires two wire conductors for the data lines, one of the transmission and for the reception. So in order to transfer and receive the data simultaneously, so you can see for simple purpose, uh, it is a simple transmission from transmitter to receiver. If I have to transmit data and I have to receive the data but not at a time, means it is a half duplex. I have to transmit the data and receive the data at a time, it refers to simultaneously. You have to transmit and receive, means it is a full duplex. So yeah, here are some of the example of this synchronous communication. Like we can go with video call conferencing and physical team meetings, phone calls, coffee break conversations, and live chat. Like you can see, these are all the live communications. Like both the way we can communicate. So benefits is deeper interactions. So if you are a manager, think of a situation if you're a manager conducting a performance reviews on your team, which would your colleagues respond better? Whereas a email thread or one-on-one video call chances, it may be a later. So for an live conversations will be more benefited and faster resolutions. If I'm getting a text to my colleague and I have to wait for their response to complete my task, whereas if I'm going for a picker phone call, I can get the immediate response, right? So these are the examples and conclusions of a synchronous communication.